So let's discuss why microplastic is a macro problem. Let's start with the history of plastic in general. After World War II, plastic production increased since it played a major role in military supply chains during the war, and they realized how versatile and cheap it is. Since then, its global production has exploded from 2.3 million tons in 1950 to over 448 million tons in 2018. Around half of the plastic ever manufactured was produced in the past 15 years. So why was that the case? Why is plastic very popular? Well, one, it's very strong, and also it's versatile. So your keyboard is plastic. A lot of people don't know this, but tea bags have plastic in them. Pens are usually they usually come in plastic, and your credit card is plastic. And take a look into your bathroom. Almost all your cleaning products and hygienic products are plastic. So they are suited for a variety of applications. They're also low cost, lightweight. They are potentially transparent material, and they have excellent oxygen to moisture barrier properties. So plastic is divided into three main categories according to size. The first is microplastic, which is anything that's bigger than 5 millimeters. Microplastic is anything that's between 50 nanometers to 5 millimeters. Nanoplastic is anything smaller than 50 nanometers. And to give you an idea, 1 millimeter has 1,000,000 nanometers. So you can only imagine how small that is. But today we will be focusing on microplastic. We have primary microplastic, which is anything that was manufactured to be used in that size range. So glitter is primary microplastic. Scrubs are primary microplastic, and microbeads in toothpaste and facial cleansers and hand soaps are primary microplastic because they were manufactured to be used as microplastic. Secondary microplastic is anything that started out as macroplastic but then was broken down due to so many factors that we will discuss later until they become microplastic, and so they are secondary microplastic. So microplastic could come from so many different sources. One, it could come from larger plastic products such as personal hygiene products. It could come from clothing, which comes in fibers. Those are known as microplastic fibers. So anytime you're using, you're wearing a t-shirt, for example, that is not made out of natural fabrics such as wool or cotton or hemp, for example, these, then it's probably made out of synthetic fibers or fabrics which have microplastic fibers. And every time you wash these clothes, microplastic fibers are released into the water. Then we have nurdles. So nurdles are plastic pellets used by the industry to make nearly all our plastic products. So they are basically the building block of any plastic product. So we will focus today on microplastic pollution in the ocean. But how does plastic end up in the ocean? Well, it could be a land-based source, which accounts for 80% of marine plastic pollution. A land-based source could be coastal pollution. So when the beach is polluted with wind or waves, these pollutants enter the oceans. It could be factories, it could be runoff or wastewater outlets. Also, the fishing industry contributes for about 18% of the plastic debris in the ocean through plastic fishing gear, which is inevitably lost or even negligently thrown away in the sea after use. Aquaculture is another source of ocean plastic pollution, as well as maritime and recreational projects near the coastal areas. Also, the increase in the immigration to these areas play a great role in the increase of marine plastic pollution. A gyre is a rotating current system that is comprised of the Earth's rotation coupled with currents of prevailing winds. And so they end up there, and this is what we end up with, except they're huge. And we have 5 of them, 5 main plastic jars. But why is microplastic a concern? Well, there has been a lot of talk on the news about microplastic and why it's a problem. The effects of microplastic are easily seen. We always see pictures like these on social media, but we don't hear much about the effects of microplastic. The effects of microplastic could be direct, like the ones we see happening by microplastic, like this. This is a zooplankton that cannot consume food normally because there's microplastic fibers that preventing it from consuming food. So of course this was taken under a microscope. So was this. This shows microplastic fibers, which are, by the way, are the most common microplastic pollutants found in almost every study. This is a short clip showing a zooplankton feeding, and the green particles are polystyrene beads, which are the same plastic particles or beads found in facial cleansers. So they are basically primary microplastic. This video shows that they're not selective feeders. So zooplanktons are filter feeders, but they do not tend to filter out plastic particles from food particles. Zooplanktons are fed upon by small fish and shrimps, which are fed upon by bigger fish, and so on. Therefore, these particles enter the food web and they accumulate by bioaccumulation in one organism and by biomagnification within the food web. So what bioaccumulation is the basically accumulation of contaminant levels within an organism. So these 3 fish are the same. They've just gotten bigger with time, and you can also see that the contaminant levels increase with time. Whereas biomagnification is basically how contaminant levels are magnified within the food, throughout the food web and the food chain. So we start out with zooplanktons that consumed plastic particles, as we watched in the video, and then fish consume a lot of zooplanktons, and the contaminant levels accumulate within these fish, and then the fish are consumed by seals, and seals end up consuming a lot of fish, and so on. So it keeps going on throughout the food chain. So this is just a simplified version of a food chain. So these are more examples of fish and their contamination of the microplastic, and we do not necessarily see this a lot or talk about this a lot, but yeah, we end up consuming these fish, and we don't necessarily consume fish gut, which is where microplastic is found, and we don't know if microplastic ends up in fish tissue, which is the parts we consume. But even there are studies right now going on about this. But even if microplastic doesn't end up in fish tissue, we have nanoplastic, which is in the size range where it could end up in the fish tissue, and that is of course a problem. Also, we have studies going on about microplastic in salts. In a study done in South Korea, scientists compared 39 brands of table salt from around the world and found that 36 brands contain microplastic. Recent studies done on water contamination found that 83% of tap water samples taken from different countries around the world contain microplastic, and that 93% of water-bottled brand samples contain microplastic. A study done by the Medical University of Vienna, where researchers studied stool samples of individuals from Finland, Japan, the Netherlands, Poland, Russia, and the UK, found that all tested samples contain microplastic. They identified 9 different types of plastic. This could be through consuming them or breathing them or drinking them, as you've seen. So we don't know if plastic in itself as a polymer is of a concern because it is considered to be biochemically inert. But plastic is still of a concern because of multiple reasons, one being pseudosatiation, especially in smaller animals. So the more plastic the animal consumes, the fuller they feel and the less nutritious food they consume. That affects their ability, their reproduction, their growth, their energy levels, and their ability to protect themselves and their offspring from predators as well as physical stressors. The second concern is plasticizer leachates. So what plasticizers are they are plastic additives added to plastic during the manufacturing process in order to change their properties or extend the life of plastic by making it heat resistant, resistant to oxidative damage, or resistant to microbial degradation. Lastly, persistent organic pollutants, which are known as POPs. So POPs are stable lipophilic chemicals and they tend to adhere to plastic. So their concentrations are much higher on plastic due to their hydrophobicity. And of course, the smaller the particle, the more surface area there is, and the more pollutants it carries. These contaminants end up in the food web, leading to bioaccumulation and biomagnification. And most POPs are considered toxic as they are endocrine disruptors or mutagenic and or carcinogenic to both animals and humans. So you can see that microplastic has negative effects on so many levels, starting from the subcellular level, where it affects enzyme activities and gene expression and causes oxidative damage, all the way to the ecosystem level, where it affects the behavior of individuals and negatively affects ecosystem function and causes community shifts. So what are the factors that affect microplastic degradation? Well, one is density. So different kinds of plastic have different densities. And the more dense plastic particles tend to sink, whereas less suspended particles tend to be suspended throughout the water column. And then the least dense plastic particles float on water surface. Also, the rate of degradation of plastic, which in itself is affected by so many other factors, one being light. So the rate of light-induced degradation is much faster than degradation in the absence of light. So let's say we have a plastic particle that is very dense. It is going to sink and it's going to be exposed to less light, and therefore the rate of degradation will be much slower than that if it was floating, for example. Also biofouling, which could occur on any surface, including plastic surface. And biofouling leads to an increase in the density of plastic particle, causing it to sink. Studies have found that mechanical integrity of commonly used plastic is lost when exposed to water as opposed to when exposed to air. And temperature simply helps initiate the process of microcracking. And the color of the plastic debris can also indirectly affect the rate of degradation, as the darker pigmented particles cause heat buildup through the absorption of solar infrared. And the more heat it builds up, the faster the degradation rate. Even though recent studies have discovered multiple bacterial strains that are able to break down certain types of plastic, these bacteria are rare in nature and they are absent in high enough concentrations. Lastly, all of the factors discussed help initiate microcracks on plastic particle surface. So microcracks are the result of oxidative degradation, where a brittle surface layer is formed. The resulted fragile surface can be easily fractured by temperature, humidity, or abrasion against sand. Once the surface breaks down, microcracks are formed. Finally, all of these factors play a role in how much microplastic is found in different depths of the sea and what size ranges are found in these depths. So how can we do better as individuals? I will discuss very simple things that you can change in your life, and you can choose what is the easiest thing to incorporate into your life and start with that. So one being is, instead of buying packaged fruits and vegetables or produce, instead of buying packaged produce, you can buy unpackaged ones. Same goes with grains and legumes, as well as nuts and seeds. You can either use jars to buy these or reusable bags. The same goes with spices. You can use jars as such to buy spices. And for pastries, you can either go to a bakery where they use paper bags, or bring your own bags if you can't find one. Also, you can just find eco-friendly alternatives to things that you use. So instead of using a regular plastic toothbrush, you use a bamboo toothbrush. And the same goes with deodorant, toothpaste, tongue scrapers. You can use a safety razor rather than a regular plastic razor. And these are just a few examples. So we discussed that microplastic fibers are the most common microplastic particles found in studies. So instead of buying clothes with synthetic fabric, you can buy natural fabrics such as cotton, hemp, wool, and silk, and these are just a few examples. You can also use filters for your washing machines.
When we have gone to talk to clothing companies or appliance manufacturers for washing machines, the appliance industry and the clothing industry haven't been helpful.
Mark says a simple filter could be added to washing machines to stop all kinds of toxic fibers from reaching our seafood.
So instead of microplastic fibers ending up in the water, which is going to end up in the ocean, you can use a filter and then collect these microplastic fibers and dispose of them in a better way. You can also use these bags instead of a filter. You can follow this hierarchy where instead of just buying something, you use what you have, and then if you really need something, borrow it. So for example, if you know you need something and you're just going to use it once, but you really need it, you can borrow it instead of buying it. Also, you can swap. So for example, if you like to read books and your friend likes to read the same genres, you can read books and then swap between each other. Thrift. You can make your own, so upcycling. And then if all this fails, you can buy. You can also follow this hierarchy where instead of directly just sending things to landfill, just refuse them in the first place. So for example, if you're handed out a free sample that you know you don't need, just refuse it. And if something is on sale and you're just gonna buy a bunch of it, but you know you don't need that much, just reduce that and don't buy all of it. Reuse what you have and repurpose what you have. Rot, so composting if you can. And then recycle. Please recycle. And if all that fails, just landfill. Thank you, and if you have any questions, please leave them in the comment section. And if you have any tips and tricks on how to reduce plastic or any difficulties maybe, let's start a discussion in the comment section.